Mathematics is a language, and like any other language, there are ways that we can translate between the language of mathematics and our normal way of speaking. So verbal expressions gives us a way of doing that. So let's look at some examples of some of the key words that allow us to convert between our normal type of speaking and mathematics language. So here are some examples that are specific to addition. So the key word that we see in number one is plus. So anytime you see plus, that's telling us to do an addition. So number one is actually an equation because we also have the phrase is equal to, which gives us our equal sign. So we can create our equation t plus 10. So that's t plus 10 is equal to 10. So from this sentence, we have our mathematical equation and we can solve for t. T in this case is 0. All right, number two is an inequality. So we have our second key phrase. So our first one was plus that alerted us to addition. The next key phrase that alerts us to addition is more than. So we have 9 more than a number. So we can say 9 plus, and a number here can be anything. So we're going to represent that with a letter, which is a variable. In this case, I'll use n. You can use any letter. So this is 9 more than a number is less than or equal to. Okay, so less than or equal to is an inequality that looks like this. So this is less than or equal to 30. All right, so the first one, number one, was an equation. This second one is an inequality. Number three is an expression. So we see the key word here is plus. So we know that this is simply 3 plus 9. And then number four, a number increased by. So here's another key phrase that indicates addition, increased by. So a number, again, that's a variable. It can be anything, like call it x in this case, increased by 9. That means plus 9 is less than. Okay, so less than is another inequality. So it's less than 48. All right, so these are some key words that indicate addition. Plus, more than, increased by. Now we have keywords that indicate subtraction. So number 5 here, 10 less than V. So less than tells us subtraction. So 10 less than V means we start at V and then we want to get 10 less than that. So we're going to subtract 10. So 10 less than V is V minus 10. Okay, minus is another key word that tells us to subtract a number minus 7. So this is again a variable minus 7. So n minus 7, x minus 7, what have you. Okay, number 7, a number less 15. Here we have to be a little bit careful. Less is different from less than. Okay, less is a synonym for minus. So anytime you see the word less without a less than, just less, you can substitute the word minus. So this is a number less 15. So that's a number, which is a variable, less or minus 15. Okay, so we have a number and then we're going to less 15. Another key word is decreased by. So 10 decreased by 6 is 10 minus 6. Less than, so we saw that again, 6 less than Q, that is Q minus 6. 6 less than Q. 27 less than 28. So that is 28 minus 27. This is 27 less than 28. A number decreased by 13. So we can say our variable, n, x, whatever, decreased by is minus and then 13. And then another less, again, 14 less 26. Remember, less is a synonym for minus. So this is 14 minus 26. Numbers 13 through 16 are keywords that indicate multiplication. So twice x, that means to do 2 times x. All right, here that's an expression. Number 14 is an equation. Actually, it's an inequality because we have is greater than. So that gives us an inequality. So this is greater than. Twice n tells us to do 2 times n is greater than 29. So now we have an inequality. All right, so we are relating two expressions to each other. Number 15, Q times. So times, of course, is a keyword for multiplication. So this is Q times 8 is greater than 15. All right, so that would look something like this. And finally, we have a time. So 11 times 7, that's just 11 times 7. Notice with multiplication, we tend not to use the cross if we have variables, right? So if I have an X or a Q or something like that, notice how I'm using the dot to represent multiplication because we don't want to use the cross because the cross could be confused with an X. Okay, keywords that indicate division. Quotient is a key one, all right? Quotient means to divide. So if I have the quotient of Z and 4, that's saying Z divided by 4. That is the quotient of Z and 4. You just go in order. The quotient of Z and 4, Z divided by 4, is greater than, that's another inequality, it's greater than 22. Okay? Half of X is equal to 40. All right, so half is telling me to divide by 2. So that is X divided by 2 is equal to, of course, that's an equation, is equal to 40. And if you like, you could also write this one as X divided by 2 like this as a fraction. It's equal to 40. It's the same thing. Number 19, divided by, of course, is a keyword indicating division. So 88 divided by 8, that is 88 divided by 8, which of course we know is the same as 88 over 8, which we know in long division form is 8 dividing into 88 like this. All right, so make sure you have the convention straight there. And then the last one, the quotient of n and 5 is 6. So again, we have the keyword quotient. So the quotient of n and 5 means n divided by 5 is a keyword for our equal sign, is 6, equals 6. All right, those are keywords for multiplication and division. And finally, our keywords for exponents. So here we have number 21. N cubed is equal to 42. So cubed is telling us to raise n, a variable, to the third power. So that is n raised to the third power is equal to 42. Okay, so this is an equation. N cubed is equal to 42. Remember, n cubed is not the same as n times 3. N cubed is n times n times n. Okay, number 22, the second power of 4. So this is saying 4 to the second power. So that is 4 to the second power, which is 4 squared, which of course is 4 times 4 or 16. All right, number 23 is an equation. U squared is 25. So U squared means U to the second power is 25. So is equals and then 25. And then finally, again, we have another cubed keyword. So C cubed, cubed means to the third power. So C raised to the third power is less than 14. So that's an inequality, is less than 14. So again, C cubed is C times C times C. All right, that's it. That's how we do verbal expressions, converting verbal expressions into mathematical expressions.